Dear students, welcome to our class on Micrometeorology of crops, wind 2. So in the first published video on wind, we tried to understand what is logarithmic wind profile, how the roughness parameter Z0 and zero plane displacement D change over different surfaces. In addition to that, we also tried to understand how Richardson number is related to logarithmic wind profile. See, the Richardson number is a dimensionless number which gives an excellent relation between the frictional forces and the buoyant forces in the atmospheric layers. It has a lot of practical applications in weather forecasting, whatnot, in precipitation, snow, whatnot, in innumerable ways. For we, the agrometeorologists, more particularly to micrometeorologists, the Richardson number, of course, the Reynolds analogy, the Nusselt number, these are all the dimensionless numbers. So they have worked enormously and then gave us wonderful constants to know approximate height of what is Z0, approximate height of what is D. They have sacrificed innumerable things and then gave us wonderful information. Just dimensionless numbers they have provided. I also tried to provide my beloved students to you all some basics, some advances on zero plane displacement, the roughness parameter, the Nusselt number, the Richardson number, the Reynolds analogy, everything I tried, which is enough for agriculture meteorology, particularly micrometeorology. From there, we start our journey in today's class. We try to understand three small graphs. The number one is the relationship between the wind speed and, of course, D and Z0 under three conditions that of course over a short grass, over a tall grass and ice. Second one is how the wind speed and so logarithmic wind profile changes with reference to neutral conditions, inversion and lapse rate, and finally over a short tall 90 centimeters tall paddy crop, which is very interesting to know. So just I would like to impress upon you once again that see the roughness parameter. The roughness parameter is the Z0 for a short grass. It is the hypothetical height from where the logarithmic wind profile holds good. Now for a tall crop where the roughness parameter is relatively slightly more than the short grass like. So from it is also a hypothetical height from where the logarithmic wind profile holds good for a smooth surface like ice or anything, paper like this, so almost zero, otherwise 0.01 centimeters height. This is how the roughness parameter Z0 changes. Now here under neutral conditions, please write under neutral conditions, the relationship between the wind velocity, and logarithm of height, is linear, and the intercept is known as roughness. Once again I try to explain to you under neutral conditions. What will happen? So the relationship between the wind velocity, and logarithmic height, is linear. It is linear. Here also it is linear. This also wind speed, logarithmic height. It is linear. And the intercept is the roughness parameter. That is the Z0 here. Roughness parameter. So the zero plane displacement is the D. The roughness parameter is the Z0. Roughness parameter. Now another important point, please write. Very interesting point. Over a tall crop like this, as compared to a short crop, or a tall crop like this, the relationship is curvilinear. For a tall crop, the relationship is curvilinear. It is curvilinear. and the departure from the straight line is known as zero plane displacement. And the departure from the straight line, okay, how much is this is the straight line, how much is the departure? The departure is known as the, okay, zero plane displacement. Zero plane displacement is the departure from the straight line of a curvilinear. Okay, this bit will come for your academic interest. Once again, I would like to repeat it. Please write. Over a tall crop, the relationship is curvilinear, and departure from the straight line is known as zero plane displacement. Zero plane displacement. This is also zero plane displacement. Okay, Z0. Okay, Z0 D value. D is the zero plane displacement. Z0 is the roughness parameter. What is roughness parameter? Earlier statement I had given for your academic interest. Those who have not understood, it is also, okay, a very, very important parameter. It is the intercept, okay, the relationship between the wind velocity and logarithmic height. It is the relationship between the, okay, wind velocity and logarithmic height under neutral conditions. The, okay, intercept we call it as the roughness parameter, which is Z0. This is the for a tall grass or a short grass I have tried to impress upon you. So from here we try to go another important okay, statement. Please write this one. Under both lapse and inversion conditions, under both lapse and inversion conditions, lapse conditions and inversion conditions, okay, the relationships between wind speed and logarithmic height are also curvilinear. Okay, both under the lapse and inversion conditions. Inversion condition, lapse condition. This is curvilinear. This statement will come as a bit in SRF. Take this for granted. Now, for short vegetation, let us go for a short vegetation. What will happen? Okay, for short vegetation, please write for short vegetation or relatively smooth surface like this, okay, the roughness parameter is relatively constant over a range of wind speeds. For smooth surface like a paper or an aeroplane going on a runway, okay, or ice, for example, is constant for, okay, varying wind speeds. Roughness parameters. Say for example, for your academic interest, I would like to share with you the values of roughness parameters quickly. For ice, plain ice, 0 centimeters. For open water in a tank, for example, okay, 0.02 to 0.06 centimeters. Snow surface 0.1 to 0.6 centimeters, imagine not meters, and short grass 0.6 to 4 centimeters, 0.6 to 4 centimeters, and for a long grass 4 to, okay, 4 centimeters to 10 centimeters. So this is how the roughness parameter over a range of surfaces you will find. Here for tall crops which bend, for example, certain crops are there. These crops sometimes, because of the wind speed, they bend and come back. For such crops, it is absolutely difficult to fix the, okay, the zero plane displacement or D value. Zero plane displacement is D value. It is very difficult because, yes, atmosphere is unstable there. Wind velocity profile is unstable. Now, please understand this interesting thing. For tall crops which bend and wave with wind, both Z0 and D are subjected to considerable variation. For Z0 and D values, what is Z0? Once again, I would like to put Z0 is the roughness, D is the zero plane displacement, U is the wind speed. Now here, for a paddy crop, I would like to share with you a very interesting example. If you take paddy crop of 90 centimeters, okay, paddy crop of 90 centimeters, what will happen? Hey, the value of D varies from, the value of D means, zero plane displacement, zero plane displacement, 35 centimeters to top of the canopy, 35 centimeter top of the canopy. That means, this much variation of zero plane displacement or D value. Okay, what is happening to Z0 or roughness parameter? It is anywhere between 7 to 18 centimeters, 7 to 18 centimeters, and of course, with wind speeds approximately 0.1 meters per second wind speeds, okay, you will get this one. Okay, now, so this complicated relationship is a result of bending of the stalks and thickening of the canopy, which causes the variation in drag coefficient. I have given enough information on drag coefficient. I don't want to repeat once again. Now here, please write 2 or 3 important statements. The value of D increases with wind speed and wind direction. Please write the value of D varies with wind speed and wind direction. No need to explain. I have explained to you in the wind 1. Now also I had explained wind speed and wind direction. Now please write the value of D is a function of the height. The function of value of D is a function of the height. Is a tall crop, it is a short grass. Okay, the density, the mechanical properties of the plant, branches, twigs, how the arrangement of the leaves, these are all the mechanical characteristics of the plant. Another important line, please write plants that stand erect. Plants that stand erect, okay, which will not bend, okay, they have the zero plane displacement, that is the D values of very high. Plants, this bit will come, the plants which stand erect will have D values more higher, otherwise, okay. In general, that's what I told some 5 minutes back. Innumerable scientists worked enormously and developed some constants. Here, the zero plane displacement, that is the D value for most of the agriculture crops. You take sugarcane of 2 meters height, you take maize of 1.5 or 2 meters height, you take a paddy crop, 50 to 80% of the height from the surface, 50 to 80% of the height from the surface is the D value, that is the zero plane displacement. This is what. Now, what is the significance of the roughness parameter? Significance of roughness parameter. This question will come in the net. Okay, please write an increase in the roughness. An increase in the roughness, please write an increase in the roughness will cause lowering of the maximum temperature. An increase in the roughness will cause a lowering of the maximum temperature during the daytime and rise in minimum temperature and rise in minimum temperature during the night time. Once again, I would like to read for your academic interest. Please check up. This bit will come. An increase in the roughness will cause a lowering of maximum temperature during the daytime and increase of minimum temperature during the night time. And the second thing is the rougher the surface, the greater is the mixing and swirling. Therefore, it helps in the evapotranspiration studies. Where there is a rough surface, there the evapotranspiration is more. Where there is a smooth surface, vice versa. This is the significance of the roughness parameter, that is the Z0. Okay, this is what I would like to share with you. Thanking you for your patient hearing.